All right, welcome back. It is time for our next lesson, 9-4 on symmetry for the geometry class. So we're going to talk about different types of symmetry. So you are very used to, I'm sure, reflectional symmetry when you, let me see here. If I was going to reflect that, I just would flip it over and trace that. That would be the reflection. Or that's one, and the reflection could be flipping it right over, and there's the other one. It's thinking of it like in a mirror where it reflects. And we also talked about reflections in, I think it was 2 lessons ago, with the golf, where we were showing how you reflect those coordinates or those points. So we're going to talk about a couple things. Number one, line symmetry. So line symmetry is based on reflections. Rotational symmetry is based on rotations of 180 degrees or less, and it's about a point. And point symmetry is the same as 180 degree rotational symmetry. So if you have a rotational symmetry of 180 degrees, it's also called point symmetry. So let's figure some of this out, because I know that right now that is not going to make a whole lot of sense, but some pictures might be more helpful. So example 1. Draw a rectangle that is not a square. So first, you guys can do that. Draw a rectangle that is not a square. How many lines of symmetry does your rectangle have? So go ahead and draw lines of symmetry and see if you agree. There's one. And you know how I know? If I fold it on that line, I know that those sides would overlap with each other perfectly. I also know that if I fold it this way on that side, they would overlap perfectly. So my answer is 2. And if you think that this is going diagonally, I'm sorry to bust your bubble, but it is not. I'm looking for a piece of paper to show you what I mean. Take an old note sheet here, because I'm going to explain this up higher. You're thinking if it's a cross diagonal this way, if I fold it that way, look at it, it does not overlap. See that? Whereas if I fold it this way, yay, it does. And if I fold it the long way, yay, it does. Wow, this paper's thick. But it does not work on the diagonals. So, back to reality. Let's get this guy down here. Okay, so it's just 2. Next question. Is a median of a triangle a line of symmetry for the triangle? Whew, lots of different questions that come to my mind. Number 1, do you guys remember what a median is? If you don't know what a median is, we got a slight problem. A median, where does that go from? Goes from a vertex to midpoint of opposite side. Okay, so that's the first thing. Of a triangle. And then it makes me think, well, what kind of triangle? We have several different triangles. So let's think about the different ones we have. We have one that could be like that, which we would call scalene. Then we would have one that like that, which we would call isosceles. And then of course we have the one where all 3 sides are the same, which is not drawn to scale, sorry, and that is equilateral. Okay, so we have a scalene triangle, an isosceles triangle, and an equilateral triangle. Is the median of the triangle a line of symmetry? Okay, well, let's think about it. The median is from a vertice to the midpoint. Midpoint's probably about there. Does that look like a line of symmetry? No. Okay, how about if it was this vertice to this midpoint? No. How about if it's this to this? No. Scalene has 0. The median is not a line of symmetry. So, no. Isosceles, though, I hope you can see that there is one, and it's from this vertex to the straight through the midpoint, although my triangle looking at it on the computer is like slanted. I can see that now, but just pretend it's not. So, the answer is yes, there is one for the isosceles. How about the equilateral? Correct, there are 3. So yes, again, pretending I drew it accurately, there are 3. It does not look like 3 because my triangle is drawn terrible. But if you had a perfect triangle, you would be able to fold it over that median and it would perfectly line up. So my apologies. I will not get the art award this year. Okay. Does this figure have okay, so that's line symmetry. So going back to the top, that's line symmetry. That's what we're talking about there. Where when you draw a line, does it have symmetry? Then we get rotational symmetry. And that's what we're going to talk about next. Does this figure have rotational symmetry? Let me try. I'm going to highlight that word. If so, what's the angle of rotation? And then here it's like, does it have point symmetry? Well, right away, when I see point symmetry, I'm thinking, well, yeah, if it has this and it's 180, then this is true. So let's just see what we got here. Is there a point that you can see where you could put your pen? Because now we're rotating. We don't need a line, we need a point. So for example, if I just put my pen straight down right in the middle, do you see how I could rotate that figure? If I could literally spin it, it would land right on top of the other side. How many degrees would I have to rotate this whole thing for this corner over here to land on top of this corner over here? Correct. 180 degrees. It would have to spin halfway around. If I just held this here and this was a loose thing and I just spun it around for this to line up on top of here. So what does that mean down here then? Since it was 180. It means yes. Because 180 degree rotation is definition of point symmetry. So you can think of point symmetry kind of underneath rotational symmetry. It's a more specific one. Okay. All right, then let's transition to the other side of this, where we talk about three-dimensional objects. And this is best looked at in the book. Help me, I can't hardly draw two-dimensional figures, let alone 3. But we're going to talk about 2 different ones here. We're going to talk about reflectional symmetry and rotational symmetry. So reflectional symmetry, now instead of talking about a line, like before we had that rectangle, we talked about a line cutting it. Now we're going to be looking and thinking, wow, hey, there's hope for me yet. All right. Oh, you can't even see it. We're going to be thinking of a plane that's going to cut through this. Look at this, guys. Isn't that good? That is pretty darn good. I am sorry. Okay, anyway. So we're going to be talking about a plane. That's going to be called reflectional symmetry. And then instead of it being rotated about a point, like before, if you had like a square and you rotated it around I can't see, rotated around that point, Now we're going to be thinking about rotating around a line. So you can think of like this pencil and something rotating around the pencil, okay, or pen. So look at 570. I'm going to grab that. The pictures in 570. All right, this is perfect. Ah, awesome. So here is what we're talking about. So here's these are all three-dimensional pictures, this whole page, right? So this is what they're talking about when they say reflectional symmetry. It's not a line like it was with the rectangle. It's an actual whole plane that when you cut through this bigger box, I have the exact same figure above that plane as I do below it. That's called reflectional symmetry. Now, rotational symmetry is, again, thinking of it like the pen. Like picturing me like sticking the pen right through like the middle of that cylinder. And then you could spin that cylinder around. Like if I had my Zevia can here and I poked right through the Zevia can, I could spin my Zevia can around my pen. That is called rotational symmetry. Okay? Because when you spin it all the way around, your image and your pre-image match. What you started with and what you end with. So let's take a look at problem number 3. That's at the bottom there on your note sheet. We'll fill in those. We're going to do example 3, but let's talk about A. Does the object have reflectional symmetry in the plane, rotational symmetry about a line, or both? Okay, so let's remember, reflectional symmetry, that's this. Is there a plane where you could cut through this bowl and have the exact same thing on both sides? Yes, you could go straight through the middle with a plane, and then you would open up that bowl and you'd have the exact same bowl on both sides. Okay, how about, oh, and let's do the other one. How about rotational symmetry? Is there anywhere you could, take the pen and put it through and it would spin around the pen and have the same thing happening all the way around? Yes, so you could put it right through the middle here and spin around it and you'd have the same thing. So yes, it has both. It has reflectional symmetry and rotational symmetry. So let's go back to reflectional. Is there a plane that you could cut through this picture and have the same thing on both sides? And the answer is yes, right? If you cut right through the handle and the spout, exactly through the middle there, you'd have the same thing when you cracked it open on both sides. How about this? If I stick this down through the middle and rotate, will it be the same all the way around? Well, no. I guess it could have been if they didn't have the handle, or if this spout was uniform, it could be. But with the spout here and this handle, when you're rotating it, you've got different things on going all the way around. So nope, it's just the reflectional symmetry. Now, got it, number 3. Does the lampshade, okay, so just the lampshade, have reflectional symmetry in a plane, rotational symmetry about a line, or both? I want you to think about that. All right, well, let's check it out. Okay, so we have reflectional symmetry. Is there a way where you can take the whole plane and cut through this shade? Yes, anywhere. Just cut right through the middle, and when you open this up, you'll have half the shade on both sides, and they'll be identical. Rotational symmetry. Yep, it is. You can stick the pen or the whatever right through there, and you will rotate it around the pen, and you would have the same thing all the way around. So it has actually both. So just to fill in your note sheet here, we did A, and we said yes, both, and we did B, and that was only reflectional. And then we had number 3, got it. And that was both. All right, short and sweet today. Get a little time to do your homework. Take care.